Alright, this is going to be the third of our reliability videos. In this video, I'm going to take data very similar to the data I'm expecting you to be able to work with on your class assignments. Instead of 20 items, I just have 10. Instead of 50 participants, I have 20. But the philosophy is exactly the same. The process is the same. So we have a test. 20 people took the test. We have 10 items on that test. First thing we're going to do is go to Analyze, Scale, and Reliability. Previously, we had done some things with doing descriptives first. I'm just going to go ahead and do everything to start with reliability analysis. And I'm going to put every single piece of data in there to start, just to show you a typical error that's made. I'm going to go ahead and click OK. And to start off, we got a negative Chromevox alpha, which really is just ridiculous to even think about. This violates all sorts of issues. But the reason we did this, and the reason I show you this first, is because this is sloppy SPSS, and this is a warning to you. This first variable is your ID variable. When you are doing an analysis, what you put in, you might have heard garbage in, garbage out. What you put into it, you get out of it. So in this case, we put ID as one of a variable in there, and that variable is going to cause us all sorts of trouble if we were trying to analyze it. So when we go back to analyze, we realize our mistake. We're going to go back and do reliability analysis without that ID. That ID is simply to keep track of people. Here it's a very simple 1 through 20. If you have 10,000 people with random IDs, this ID variable could become both important and not so simple. So let's go ahead. We've done split half before in a previous video enough, so I'm not going to go back through and do split half. I'm going to focus on alpha. We go to statistics. I'm going to ask for descriptive statistics. I'm going to ask for a scale value of item deleted, correlations, and covariances. Many of the things I'm asking for your homework assignment, but also I'm conducting these so you can see how useful, some of the utility for them. I'll go ahead and conduct an F-test this time around. Actually, I'll wait to conduct the F-test for later on as we go through our analysis. So let's keep it at none for now. Go ahead and click continue and OK. Well, first we get this warning that the covariance matrix is 0 or approximately 0. What happens when we do matrix algebra is sometimes we need to divide by determinant, and if it's 0, this blows all of our mathematics up. For this, we should be okay for most of what we want to look at. If we were doing a factor analysis, we'd be in big trouble here. And this will happen when you don't really have continuous measures, especially in extreme cases with like binary data. Enough on that. I can talk more about that in class. But just know that Chromevox alpha is not typically, although it can be, is not typically calculated with matrix algebra. I showed how to calculate that with summing variances and the total variances in last video and in class. We go down and we get a Chromevox alpha measure, and we see that it's 0.59. I'm going to leave the Chromevox alpha based on standard items separate for now. We have our item characteristics. Again, we're getting pretty good at understanding what a mean is for our item. It sort of starts to talk about difficulty. If we see a 0.2 or 0.1, we know that's the proportion of people that got that item correct. If we see a 0.7, we know that's the proportion. Or 0.95, well, looks like everybody got that number correct except for one person. We could go check that. Item 3, yeah, pretty much everyone got that item correct. And that's just what the item means are telling us, the variance. Well, in this case, we reported the standard deviation. We could take the, square that standard deviation and get the variance component. I have item total. I have item by item correlation matrices, the correlation amongst your items. You can see that item 1 and item 2 are positive. Item 1 and item 4 are negative. Some of these negative directions are a little concerning to me, especially when I just eyeball number 10 seems to be a negative correlation to everything. Yeah, I just had you select I just went ahead and selected the covariance matrix so you could see where we get this from. As a reminder to you from your introductory stats course and earlier this semester, the correlation matrix is a standardized variance covariance matrix, or the reverse. We can think about the variance covariance matrix as an unstandardized correlation matrix. And then finally, I have item total statistics, and I asked for a few things here. We're going to go and focus on two of the columns for now. Later on in this semester, we're going to get much more into item analysis, but for here, our goal is going to be a cleaning process. And what that means is we want to have items we want to be able to select out items that are the most reliable set of items or subset of items for our test. So we piloted 10 items. And what we find here is that some items aren't performing well. And just as a descriptive, we can see that, like, well, some of these items are correlated negatively to everything. Well, corrected item total correlations tell us something about our data. This is the corrected item total correlation. It tells us how that item correlates to someone's total score. So how does that, if we were to take all of the items, get a total score, which your grade would be effectively on those 10 items, how does one item correlate to that total score? So we can see item 1 has a 0.5 total correlation, item total correlation, which is fine. But we scan down and we see item 4 and item 10 have negative values. This means that if you get your total score, your grade overall, these items have a negative relationship to that, which does not make sense. These are the items that we could target for removal. Another way we can do this is by looking at what would Chromevox Alpha be if I deleted an item. And we would like to delete an item that from our reliability analysis that would most increase alpha. And we can scan down this row and we can see that the highest value, that if we deleted item 4, also the highest negative item total correlation, that we would end up with Chromevox Alpha if deleted at 0.7. Now, people will be tempted, you will be tempted at times to skip steps, but please don't. Item cleaning, cleaning your data for reliability is an iterative process. When you remove one item, everything can shift around. So there's a couple items that are questionable here. Item 4, item 10, maybe even item 3 looks like a lower item total correlation, but maybe not. We'll take a look at it in a moment. But don't just remove both these items. Remove items one at a time, and then rerun your analysis. So we're going to go and we're going to say item 4 is most suspicious and has a problem. It could be suspicious for several reasons. When we get into item analysis, we're really going to pick through those reasons to see if we should be removing an item. And we're not just going to remove items on our own. We're going to talk to subject matter experts. But for now, for the purposes of finding the subset with the highest set of reliability, without, while trying to maintain a reasonable set of items, we're going to go ahead and just start by removing item 4. We'll go back to our data, and I'm going to go analyze back to our scale and reliability analysis. I'm just going to take item 4 out. Leave everything else the same. Well, we now have Chromevox Alpha as predicted of 0.714. I'll go back up a second. Our previous analysis, it predicted that if we remove that item, we would get a Chromevox Alpha of 0.714. Now we still can see our item statistics and our correlation matrix and our covariance matrix. And now we only have 9 items to look at for our reliability. Well, as we go down, we can see, not to such a big surprise, that item 10 has a negative almost 0.3 value. In our previous analysis, it's actually slightly smaller, so we can see that we removed one item and things have shifted around a bit. Item 10 is going to be removed because it negatively relates to the rest of our items, which is going to have a pretty big impact on our total Chromebox alpha value, we can also see that Chromebox alpha, if deleted, that we would increase to 0.792, starting to get to a reasonable alpha value of zero point 0.8. So at this point, I'd like to make a couple comments about how to go through and complete the cleaning of this. So we got started. We know that there's a couple bad items. Any item that's negative total correlation is either functioning wrong, maybe it's been coded wrong, something's wrong with it. We'll, like I said before, investigate more in item analysis. But we also want to increase alpha. We don't want to do so by throwing out all of our items. So our goal is to maintain a reasonable set, really maximizing the items we can retain, but by also increasing alpha and getting rid of those items that specifically have, in this case, negative item total correlation. So before I remove item 10, we just need to be cautious not to try and maximize trivial elements of Chromebox alpha. I will go ahead and remove item 10, talk about a rule. In this case, we're going to set that any item total correlation, or we should have set this before we started, just as good practice, we're going to say item total correlation should be above 0.2. Not an absolute value. Negative 0.2 is just as bad as negative 0.3. Negative values go. But for now, I'm just going to set a value of 0.2 as our corrected item total correlation. And we're going to try and maximize Chromebox alpha. But we're not going to throw out an item if it is 0.2 or above. So we can see here that both item 10 and item 3 fall under that characteristic, but item 10 is the worst of the two, and we will increase alpha the most. So I'm going to go ahead and remove item 10 iteratively, just pull out item 10, and we will see alpha has been increased. I can go ahead and circle that, I believe, and alpha has increased. And we have our item total statistics again. We can go down this value for Chromebox alpha if deleted. And we can see we could increase it just very marginally more. Go across and look. Well, lo and behold, item 3 is now well above that threshold of 0.2. And in some cases, you might set that threshold as low as 0.1. We'll talk much more about that again when we get to item analysis. But for now, we would stop. This is where we would stop. We don't want to get rid of all of our items. There's no reason for such a trivial change, that is, alpha is 0.792. To raise it 0.004 points is not worth it. And this is where we would end our reliability analysis if we were following that joint rule. If we weren't, I'll go ahead and do that just so we can see what happens here. We're going to end up throwing out a whole bunch of items for no good reason. If we were just saying, okay, well, let's try and maximize that trivial amount. We'd love to maximize alpha if we can. So I'm going to go ahead and throw out item 5 first, because that one actually is just the simple rule of maximizing alpha. I'll just quickly go down. Oh wow, we can increase alpha at 0.089 from our current alpha of 0.796, I believe. Yes. I was going to go ahead a little bit faster and pull out those values. 3, and now alpha is 0.0809. Oh, we can increase it by pulling out alpha item 6. And we're going to end up seeing we're going to throw everything away. Well, just about everything. We can increase it now to 0.848, which is reasonably high alpha, but we haven't really gained much. And we're now down to less than half our items. Oh great, we can increase it to 0.893. 2. And then finally it's going to tell us we can pull out one more item. Perfect alpha. So if we pull out item 1, and we will end up with perfect reliability between those two items. I mean, with those two items. And we can see we basically oh, maybe I did not. Yeah, just go ahead and pull that out. Okay. And we can see that we have no more things that we can pull out, perfect item total correlations, etc., etc. But this would not be a great test, a two-item test, and you can probably envision this with a lot of items, 100 items. You can also probably, if you've worked on item development before, realize that 10 items can take you a long time to write good items for. We wouldn't want to throw out 8 of our 10 items. So our rule, we'll go back to where our rule kind of stopped us, which was go ahead and just hit reset and put back in our items. We had pulled out items 4 and 10. Go ahead and click OK and got our alpha of 0.792. This would be where I would iteratively have stopped.